Hello everyone, I'm going to attempt to make this video on my computer today. Had some success earlier, so we'll see how this goes right now. So I'm going to do one of the connector problem examples. So in this problem, there are 11 locations that require access to power. The 11 locations are represented by the red vertices shown on the network graph on the right. These locations are represented by the vertices. They're red. The dashed lines in the network diagram represent possible cable connections between adjacent locations. The numbers on the dashed line show the minimum length of cable in meters required to connect these locations. Find the length of cable needed to provide power to each location. So we need to connect all the different vertices, the red dots, on this network. We need to figure out the least amount or least length or least cost of cable needed to connect all these locations. So when you do one of these questions, a good way to start, instead of trying to figure out which one of the vertices you should pick, is pick the one that only has one edge connecting it to the network. So I'm going to pick this one right here. So that one is kind of the one that you're going to use. So you're going to use PIM's algorithm to now make your decision. So instead of drawing it out today, we're going to just look at it and do it visually. So between 60 and 70, which one of those two is the smallest number? It's going to be 60. Between 40, 70, and 70, what is the smallest number? 40. Between 70, 70, 60, and 70, what is the smallest number? Between, and this is like every time you go through this, between 70, so you're looking at each path each time. So between 70, 70, 50, 40, and 70, what's their smallest path? Between, getting tired yet of this? Between 50, 50, 70, and 70, what's our smallest path? Well, it's both 50, so I'll just go down and I'm just going to go to here. So now we repeat between 70, 70, 50, 60, and 70, what's our shortest path? Between, here we go, 70, 70, 40, 60, oh, you don't need to worry about that one anymore, and 70 and 50, what's our smallest number? And then basically you have two dots left to connect. You know that this one is one of them. This is the other one. I know, beautiful, isn't it? So once you have that all done, you have each one of these done. I'm going to switch my pen so that way we can kind of keep organized. Now you got to add it all up. So that's 60. Why am I using my mouse for this? I'm going to use my hand. You have 60 plus 60 plus 40 plus 60 plus 40 plus 50 plus 50 plus, I'm going to run out of room here because I can't write below that line. 60 plus 4 is 100, so I'm going to do those two together. That's 100. And then I'll do plus 50. So get out your calculator and quickly do that up. I'm just getting out my calculator so I can do that up. 50 plus 60 plus 60 plus 40 plus 60 plus 40 plus, I got 510 meters. So find the minimum length of cable, so therefore 510 meters of cable required, and you could probably write it a lot neater than I can, just because you have a little bit more space. So there is the example. Using PIM's algorithm, I'm always picking the shortest of the paths to help pick which way you're going to go. I hope that helps out. Take care.